In lesson 28, we're going to look at another triangle congruency theorem of side angle side. But first, I want to talk about included sides and included angles. Just so we know what that is, because that's what we'll get into with side angle side theorem. If we have a quadrilateral here, and we want to know what the included sides are, included side of angle A and angle B would be, well, we find angle A, we find angle B, and the line that is between them is the included side. So AB would be the included side. It's pretty easy. And then the included angle between BC and CD, well, the included angle there would be angle C. And so that's all the included angle and included side is, but I just want to make sure that y'all know what that terminology means. Now that we know that, let's look at our next shortcut, all right? Once again, these are all shortcuts to know for triangle congruency. So if we know side angle side congruency, then we know that the whole triangles are congruent. So side angle side might look like this, side angle side, just how it sounds. And once we know that those are congruent, we can say, once again, therefore, this is an acronym you're going to see a lot, CPCTC. Remember, corresponding parts, or corresponding parts of congruent triangles are congruent. So therefore, since we know that the triangles are congruent by side angle side, we know that the corresponding parts are congruent. What are corresponding parts? Let's call this A, B, C, D, E, F. Well, therefore, angle C and F are congruent. Side DF is congruent to side AC, and D is congruent to A. So now all of our corresponding parts in these triangles are congruent because of side angle side. So let's just look at one example of how this might be put into a math equation. Example 3 says find the value of x to make the triangles congruent. So it shows us that these sides are already congruent. Excuse me. So if we can prove these angles are congruent, I'm just going to call this B and this D. If we can prove that B is congruent to D, then we could have side angle side. And it already gives us measurements. And so if we want to prove they're the same, we simply need to set them equal to each other. So 6x minus 27 equals 4x plus 7, because we want them to be equal to each other to find x. Then we just solve. Add 27. That's 34. I'm getting really slanted in my writing. Subtract 4x. I'll try to fix it. Subtract 4x. You get 2x equals 34. So therefore, when you divide by 2, x equals 17. And that would prove that the two triangles would be congruent because now their angles are congruent. But that is side angle side congruence theorem.